Hello everyone, my name is Saad. I'm with Aviatrix. We are starting a new series called Aviatrix Deep Dive. In this series, I'll be discussing about Aviatrix platform, its components, the architectures, also the enterprise challenges and their solutions, and various features that Aviatrix introduces every quarter or so, and everything we will discuss in detail. In today's session, I'll be discussing about the architectural components and deployment from any CSP marketplace. How does it look like? We go into an architecture, multi-region, multi-cloud architecture on AWS and Azure. Then we will talk about why Aviatrix control plane is so unique and why Aviatrix uses the distributed data plane and what advantages it can provide you in your architecture. And last but not least, we will discuss a typical brownfield migration in AWS environment. With that, let's talk about the Aviatrix architectural components. So the first Aviatrix architectural component is the brains of the entire platform. It's called Aviatrix Controller. Aviatrix Controller sits in the management and control plane. Anytime you have to do the configuration, onboarding your accounts, any programmatic access, you log into the Aviatrix controller. It's a single controller for your entire multi-cloud environment. It utilizes on the EC2 instances or VM, but with high availability. The second component is Aviatrix Gateways. This is a data plane component. And you need this thing because it's going to provide you a common repeatable architecture across multiple regions and multiple cloud. You also need the Aviatrix Gateway for any advanced networking and security functionality. For example, you have a challenge of overlapping IPs, or you wanted to have end-to-end encryption, or maybe any kind of anomaly detection. You use the Aviatrix Gateways. Third component is Aviatrix Copilot. Aviatrix Copilot provides you the security, visibility, and troubleshooting tools. We are going to dedicate multiple sessions just on Copilot because how rich this component of the Aviatrix platform is. All right, with that, let's talk about how the deployment looks like. So when you are ready to deploy the Aviatrix platform, then you need to log into any CSP marketplace, and then you subscribe to Aviatrix. After subscription, you can deploy the Aviatrix controller. At this time, just remember you have a static public IP available for you. After the reload, it should not lose its IP, so that's why we require a static public IP. You deploy the Aviatrix Copilot pretty much in the similar fashion. And then you should always have the permissions, the IAM permissions, because what Aviatrix Controller is going to do, Aviatrix Controller is going to create the IAM policy. It needs those permissions to deploy its gateways, the data plane component, and also creating the subnets, managing the routing tables, creating the native constructs, and all those kind of things. But all these IAM policies are all customizable. So based on your use case, based on the functions you're using, you can tweak those IAM policies. After that, it's time for you to onboard your accounts. If you are in a single cloud, then you onboard all those. If you are in multi-cloud, then onboard all your accounts. It doesn't matter whether you have tens of accounts or hundreds of thousands of accounts. Since you have already deployed the controller and then the Copilot, you don't look for Aviatrix Gateways subscription in any marketplace. You are not going to find it because controllers are deployed directly from the Aviatrix controller itself. All right, so let's discuss a little bit about how you can secure the Aviatrix controller and then the entire platform. For controller, what you can do, you can have a native load balancer in front of the Aviatrix controller. And to make it even more secure, you can add a WAF in front of the load balancer. Then controller also has a specific, a very unique feature, which is called the controller security group management. So I'm going to just short this thing as controller security group management feature. What this feature does, it will let you define a subnet or multiple subnets from where your users are trying to access the Aviatrix controller. So it's going to open port 443 in inbound direction on the security group itself. What this feature also does, whenever you deploy the Aviatrix gateway, it will automatically open the gateway IP for the inbound access to the Aviatrix controller, because controller and gateways needs to communicate with each other. So if you have hundreds and thousands of gateways, then you really don't have to manage it. The security group. Aviatrix controller does this thing automatically. For controller, you can also do the SAML, like Okta or any other SAML provider you can use for even securing the controller even more. First, gateways, a similar feature like a controller security group management, which is called the monitor gateway subnet. So when you deploy the Aviatrix gateway, these gateways always deploys in its own dedicated subnets that was created or that is going to be created by the Aviatrix controller. And the controller never lets any other instances gets deployed in that particular subnet. And if somebody tries to do this thing, then it will get you alerted on that. So that way it's very secure. You can also encrypt the controller and gateway. And after that, you always have an option, and I would highly recommend you guys to use the RBAC functionality, which is a role-based access control functionality, to even further secure your Aviatrix platform. One question usually comes up is what public IPs Aviatrix controller talks to. Aviatrix controller talks to the licenses server for obvious reasons, also communicates with the release server because every quarter or so Aviatrix releases a new feature for you to utilize. Trace logs, at the time when you need some troubleshooting, you need to discuss this with the support team. You need to upload your trace logs. And the messaging between the gateways and the controller, so there is a messaging server. And the Aviatrix gateways also needs to communicate with some public IPs when it's creating an IPsec tunnel. These IPsec tunnels can be within a cloud, or it could be with on-prem with your partners or with your branches, or maybe to the data centers. For all those public IPs, it communicates with, because the IPsec communication is going to happen over there if the medium is internet. Okay. So now I am going to draw the multi-region, multi-cloud architecture with AWS and Azure. I'm drawing AWS and Azure. And it has two different regions, region 1, and then we have region 2. Same thing in Azure, region 1 and region 2. Let's create the application VPCs. Application VPCs are also called the spoke VPCs in Aviatrix transit architecture. The top layer is the spoke layer, while the bottom layer is the transit layer. So let me write it down over here. After creating the spoke, by the way, these spoke application VPCs, you can ingest these spoke VPCs or the application VPCs as soon as you onboard your cloud accounts, any CSP accounts. All these spoke VPCs and then the VCN and the VNets get ingested by the Aviatrix controller and have the visibility of those. Now you need to deploy the Aviatrix spoke gateways in spoke And you always deploy in HA, like 2 spoke gateways in each availability zone, like the way I'm drawing it. In transit, you deploy a transit gateway. When you connect spokes with the transit, you actually create 4 tunnels from each spoke VPC towards the transit. So a spoke has a connection with the transit gateway 1 and also with the transit gateway 2. Spoke 2 has the same connection, like the way I'm drawing it. So as you can see, it's very clear that what Aviatrix platform is doing is creating a complete mesh, active mesh between the spoke gateways and then the transit gateway. So every VPC has minimum of 4 connections or 4 tunnels to the transit. So for the sake of the simplicity of this diagram, moving forward, I'm going to just draw 1 connection between the spoke and transit, but underneath the hood, there are actually 4 tunnels. The way you can connect the spoke to the transit, there are 2 different ways. And the way I've drawn it right now is the first method, which is the standard encryption. You can also utilize the high performance encryption where we deploy n number of tunnels, and we will discuss this thing in a separate section. All right, now let me redraw a number of VPCs in region 1 and region 2. By the way, I'm just drawing 2 VPCs, but this could be hundreds of VPCs in region 1 and region 2. For the simplicity of the diagram, I'm only drawing 2. Now deploy Aviatrix gateways in all the spoke and then the transit. Now let's connect the Aviatrix spokes with the Aviatrix transit gateway. Again, I'm going to this time draw a single line between them, but basically the single line means there are 4 connections or 4 tunnels. In a typical architecture, the applications are protected by next generation firewalls for layer 7 inspection. So I'm going to just drop the firewalls over here as well. Now if you take a look at the regions, the region number 1, region 1 applications can communicate with the applications within the region 1. It cannot communicate with the region 2 of the AWS or region 1 or region 2 of the Azure because there is no connectivity. Now let's draw the 2 data centers that this particular enterprise has. Let's call it region 1 DC. And this one, let's call it region 2 DC. They have some WAN routers over here. We also deploy for the on-prem environment. Aviatrix has the hardware appliance called Cloud and Devices. Acts pretty much the same way as the Aviatrix gateway in the cloud. And you also deploy this thing in a HA fashion. So I'm just going to call it as CN1, CN2 in both data centers. In order to connect your on-prem environment to the cloud environment, which basically means the hybrid connectivity, all you need to do is to connect your cloud and devices to the respective regions. Again, there will be n number of connections over here. I'm not going to draw all those connections. I'm going to just draw a single line which is going to represent n number of connections. So region 1 will be connected to the region 1 data center in AWS, and same thing with Azure. Now we are going to do the same thing for region 2 data center. It will be connected to the region 2 in AWS, and same thing with Azure. Now you can see the applications have connectivity with the data centers, but the regions cannot communicate with each other. The applications across the cloud environment cannot communicate with each other at this time. Let's do that also. So there are two different options when you are connecting your regions within a cloud, either over internet or co-location. It does not matter to Aviatrix what is your preference. Typically, your preference is based on the latency, performance, and how much private you wanted to keep your communication between your application across the regions and across the clouds. Okay, now I'm going to draw this layer over here, which is basically a colo, or you can call it an internet also. So I'm going to write it down, colo, or iNet. It could be anything. Now, when you wanted to have a communication between the region 1 and region 2, then you can connect the transit using the transit connectivity, either using the colo, like Equinix or Megaport or something like that, or using the internet. You don't have to create the reverse direction connection. It will be automatically done by Aviatrix. Now, region 1 and region 2 within the AWS connectivity. Now you need to go back into the AWS and then show your intention that you wanted to connect your region 1 with the Azure region 1 and region 2 also. So all you have to do at this time is extend this line first to this and then to this guy. You need to repeat the same thing for AWS region 2, and that will take care of the communication between your region 2 to region 1, and then region 1 and region 2 in Azure. So now you have a full mesh between your regions and between your clouds. So if we take a look at the communication between the applications, then you can see the application in region 1 spoke can communicate with region 2, any spoke over there, or even across the Azure environment as well, region 1 or region 2. And they all also have a communication to the on-prem environment. So this is how a typical architecture across multiple region and multi-cloud looks like. All right, so let's talk a little bit about the Aviatrix control plane. So Aviatrix control plane is a centralized control plane. So let's draw this out. So you might need a VPC. I wanted to recommend that you have a dedicated VPC. Call that a management VPC. And then over there, you can deploy the Aviatrix controller and Copilot. You can deploy a controller either in AWS or Azure. It's your choice. Right now, I'm deploying it in AWS. This controller, what it's doing, first of all, this is a centralized control plane. It's managing your VPC, all the VPCs over here, and then the VNets, and if you have the OCI environment, GCP environment, like VCNs, all the routing tables through this Aviatrix controller. So it's going to work in your multi-cloud environment. Controller also manages all the gateways, right? So when you have to upgrade the gateways, it will be taken care by automatically. When you have to scale up or scale down, Aviatrix controller will take care of this thing for you. Aviatrix controller also orchestrates the native constructs. For example, when you deploy the Aviatrix, when you deploy the VPCs or the VNets, or everything that goes inside that the routing tables, the subnets, the IGWs, and all those kind of things is being taken care of by the Aviatrix controller automatically. Aviatrix controller also automates the third-party networking devices like next-generation firewalls that I'm showing in every single transit over here, or your load balancers as well. Now, if you want to talk about the data plane aspect, the data plane is distributed. You can see the Aviatrix gateways are in each VPCs in the VNets over here, which is providing a distributed data plane architecture. That is very, very important because that helps to provide you guys the advanced networking and security features. And we will talk about this thing in almost every single session that I'll be doing it. All right, so let's talk about a typical brownfield migration. How does it look like? But prior to that, let me erase this. All right, so let's talk about a typical brownfield migration. And in this scenario, I'm going to use AWS environment. For example, if customer has hundreds of VPCs, but for the sake of simplicity, I'm going to draw only 2. And then they do have TGW environment. And the VPCs are connected to the TGW as an attachment. So here is a VPC 1, here you have VPC 2, and then they also have the on-prem connectivity, the hybrid connectivity like this. Now, for when you are migrating it over to the Aviatrix environment, the first thing you need to do, you need to create a new VPC, or if you already have a shared services or management VPC, that's great. All you have to do at that point is deploy the Aviatrix controller and Aviatrix Copilot in there. Once you deploy that, after that, what you need to do, you need to go back to your controller and create a transit VPC. This is your transit VPC. And then you drop a couple of Aviatrix transit gateways in there. After creating the transit VPC and dropping the transit gateways in there, you want to make sure there's a connectivity between the AWS TGW and Aviatrix Transit. You might have the connectivity with the on-prem using either a DX or using any kind of IPsec connectivity. It doesn't matter right now at this point. All you need is a connectivity. For example, if you have a 10 gig connectivity, a 10 gig DX, then you want to make sure that you have some back-to-back connections with Aviatrix Transit gateways. And you can easily go 10 gig plus of throughput over here like this. At this time, you wanted to go back to your controller and drop Aviatrix gateways in VPC 1 and VPC 2. These are spoke gateways. And if you have hundreds of VPCs or thousands of VPCs which you are migrating, you do the same thing. And don't worry at this time when you deploy the Aviatrix spoke gateways. It's not going to change any routing. It's not going to change anything. The only thing which it's going to do is going to create its own subnet and then deploy these spoke gateways in that particular subnet. Okay, now at this point, you are ready to migrate the VPC2 along with its application. At this point, you need to just remove this connection, which is the attachment. And then create a connection between the spoke and then the transit like this. Now you can see VPC2 can communicate with the VPC1 application using the transit, then using this TGW and transit connectivity back to the TGW and then VPC1. So that is the path it's going to take. And if VPC2 needs to communicate with the on-prem, it's going to take the route of the transit, then to TGW, and then to on-prem. Now you are ready to migrate the other VPCs also. So I'm going to just remove this attachment to the TGW and connect the spoke gateways to the transit gateways like the VPC1. Now the entire region can communicate with each other, all the applications using the Aviatrix Transit, VPC1 to the transit, and then VPC2. For the on-prem connectivity, it will send the traffic over to the TGW and TGW to on-prem. At this time, you can deploy Aviatrix cloud and devices over here, and then connect the cloud and devices to the transit. Again, I'm showing only one connection, but it could be n number of connections. Or the second option, if you are not looking for any kind of encryption, then you can connect using your WAN router as an IPsec connectivity back to the transit. When you have achieved this connectivity, at this time, you can easily remove these connections. And the TGW completely over here. Now, all your connectivity at this point is using the Aviatrix transit. Your east-west connectivity and north-south connectivity are all via the Aviatrix transit. So that's how it's going to look like. So this is what I have for this particular session. In the next session, I'll be discussing about the Aviatrix transit, why we need the transit, what is the transit, and when you connect the spoke gateways to the transit gateways, what impact it has on the subnets, the routing tables, and all those kind of things, and we go into the details of those things. With that, I will see you in the next session. Thanks for watching.